Okay, hello everyone. So today we'll see that is lecture 2, that is of unit 5. That is, as I said, that I will be continuing with the topic of that is applications of calculus of variation. So as we discussed some what do you mean by calculus of variation, wherein we are finding solution or the output, right, of any integral of the type that is integral of the type x1 to x2, and f is a function of x, y and y prime, right? So let us start with the application, and we shall start with the application that is known as geodesic. So what do you mean by geodesic? Geodesic, it is the shortest line between 2 points, okay, on a specific surface, right? So we are finding what in a geodesic, whenever a problem arises contains the word geodesic. So what you need to find, you need to find the shortest distance that is between shortest line between 2 points on a specific surface. So as I have given you notes, right? So in notes this was given, that is application of calculus variation, wherein I have written that is geodesic. So given two arbitrary points A and B on a surfaces, there exist infinite number of curves, right, on the surface having A and B as their extremities, that is any point that is A and B. Now what we're doing is I want to find the shortest line or the distance from A to B of these curves, that curves whose length is least. So can you see this? So it is least is called, that is geodesic, between the points A and B on the given surface, right? So what is the given, that is least length between the points A and B is called that is geodesic. Now this question is given as that is prove that the shortest distance between 2 points in a plane, okay, is along the straight line joining them, right? Or the question might be also given as prove that the geodesic on a plane or are straight line, right? Or the question might be also given as prove that the shortest distance between 2 points is along a straight line. Now what I do is, for solution I write it, that is let x equal to, that is let a is equal to x1 y1 and b is equal to x2 y2 be the 2 points, given points, and s the length of the arc joining these 2 points. So let me consider this as s, right? So the curve, you can say, right? And then s is equal to, that is it is integrated, that is taken the points, that is x1 and x2. That is what I have explained in the very first class, right, of lecture 1 of unit 5. And some part of, that is ds. If I take some part of ds, and if I take tangent over here, you can take tangent over here, you can take tangent over here, sorry, from here. So any tangent you can take and take some part of it, right? Suppose if I am taking sorry, this tangent, and some part if I take this, that is some ds, right? Okay, fine. So this turns out to be, that is at any point. So integration of over x1 to x2 square root of 1 plus dy dx the whole power square. So here, which I had already done, that is the arc length of the surface. So this is arc length of the arc between a to b ds is always given by, that is here in my case it is, in our case it is x1 to x2 ds square root of 1 plus f dash of x, here it is dy by dx the whole power 2 dx, right? Now coming back here, so this was it, fine. Okay, so this I can write it as in the form of, that is x1 to x2 square root of 1 plus y1 prime square dy. So let me consider this as equation 1, and over the given points, that is y of x1 is equal to y1 and y is equal to x2 is equal to y2. And now if you have an observation, what type of a problem this is complete a functional, you can say. This is a functional, right? Now if S satisfies this particular curve, okay, this particular curve satisfies the Euler's equation, then it will be minimum. So what so this is a variational problem. So any variational problem, that is f is a function of x, y and y prime. So this is a functional, and this can be evaluated by solving for making use of Euler's equation. Then it will be minimum. Now by Euler's equation we have, this is the Euler's equation, right? Dou f by a dou y minus d by dx of dou f by dou y prime equal to 0. Here in equation 1, f is, now my given functional is, that is square root of 1 plus y prime square. So it is square root of 1 plus y prime square. Now f is independent of what? It is independent of y. So that is dou f by dou y is equal to 0. Therefore d by dx of dou f by dou y prime is equal to d by dx as it is, this as it is, into f is a function. So what you do, you differentiate it partially with respect to y prime, that is square root of 1 plus y prime square, right? Now d by dx of this turns out to be, see here, this square root sign, it will be 1 by 2. So it is of the form x raised to n. So 1 by 2, 1 plus y prime square, and that is n minus 1, that is half minus 1, into dou by dou y of, that is function of a function. So dou by dou y prime of y1 y prime square. Therefore d by dx of, after evaluating, you get y prime divided by this comes to the numerator, that is square root of 1 plus y prime square. Now putting these values in equation 1, so obviously dy by dx is 0. Sorry, it is dou f by, it is independent of y, right? So dou f by dou y is equal to 0. Now here d by dx of y prime divided by square root of 1 plus y prime square, or see this d by dx can be, and that is or d by dx of y prime divided by square root of 1 plus y prime square equal to 0. Therefore on integrating we have, that is y1 prime divided by square root of 1 plus y1 y prime square is equal to c. And now if I take this, that is squaring, what will happen, that it turns out to be y prime square is equal to c square 1 plus y prime square. Now again rewriting this, that is y prime square, that is common over here. So this is 1 minus c square is equal to c square, or y prime square is equal to c square divided by 1 minus c square is equal to m square. Therefore y prime is equal to m, or this is nothing but dy by dx is equal to m, that is the slope, or you can say tan theta, right? Therefore on integrating this, I get y is equal to, integrating with respect to x, so y is equal to mx plus c, which is a straight line, right? So this is your equation 2. Now given condition, that is yx1 is equal to y1 and yx2 is equal to y2, therefore making use of this, that is it is expressed in terms of y is equal to, that is f of x, right? Fine. To which this functional, the given functional is minimum, this given functional, right? Now yeah, so what is the value of this? So mx1 plus c is equal to y1 and mx2 plus c is equal to y2. Therefore on substituting, subtracting, we get, so subtracting, what do you get? y2 minus y1 is equal to m x2 minus x1, or m is equal to y2 minus y1 divided by x2 minus x1. Subtracting 3 from 2, we get, that is y minus y1 is equal to m x minus x1. So y minus y1 is equal to, the value of m is here y2 minus y1 divided by x2 minus x1 into x minus x1. So this turns out to be your output, which is the shortest distance, that is minimum distance, right? Okay, fine. Okay, now let me have my second problem, and that is find the geodesic, okay, on the surface, given that the length of the surface is, and that is s is equal to over the integral, that is x1 x2 square root of x 1 plus y prime square. Now this f is a function which is expressed in this particular form, okay? So f is equal to square root of x 1 plus y prime square, which is independent of y. So definitely dou f by dou y is equal to 0. So let me consider this Euler's equation, and reduce it to that and this particular equation reduces to minus d by dx of dou f by dou y prime equal to 0, or dou f by dou y prime is equal to, that is constant. Yes, fine. Then so 1 divided by, so what is this? Okay, so this turns out to be 1 divided by 2 square root of here. Okay, so here it turns out to be, that is d by dx of, that is 1 that is in differentiation of that is dou f by with respect to y prime. So this is root x, so it is 1 upon 2 root x into x to y prime equal to c. Therefore taking that is square root of x y prime divided by square root of this 2 and this 2 gets cancelled, and here it is 1 minus y prime square equal to c, right? Therefore it is x y prime square which is equal to, from here, okay, which is equal to c square 1 plus y1 y prime square, or y prime square into x minus c square, which is equal to c square. Therefore y prime is equal to c square root of x minus c square. Therefore y, therefore on integrating, or take this differentiation sign this side, okay, so this turns out to be your integration, right? So whatever constant term is there, you take it outside, or integrating both sides. So y is equal to c integration over dx square root of x minus c square plus c1. Therefore y is equal to 2c square root of x minus c square plus c1 inside the bracket. So on, that is, this turns out to be y minus c1 square, which is equal to 4c square in the bracket x minus c square. Okay, so this is y square is equal to 4ax, right? So which is for, that is, it is a parabola. Fine. Okay, okay, now let us see that is now let us see another application. The first one was geodesic, that is shortest distance between A and B line. Now see we'll see what is this catenary. Okay, so in mathematics, a curve that describes the shape of a flexible flexible hanging chain or cable, then the name derives from the Latin, it is catenaria, which is chain, right? So let me explain this with not this, yeah, see here. This catenary application is very important, and you have come across this many a times. You have also observed it, right? Fine. So this catenary problem usually arises in hanging chain problem. Or see here, if a heavy uniform string or chain, okay, it might be a string or it might be a chain, hangs freely between 2 points, right? Hangs freely between 2 points which are not in the same vertical line, then the curve in which it hangs is called a catenary, right? Now the best example is the street lights, or the electric poles. From one, this is one electric pole, this is second electric pole, and this is third electric pole. So if you see the wire like this, then you see like this, then again it is connected like this. So this is between some point A, B, C, D, right? Suppose actually it should be like this, right? A bit bent. Fine. So what will happen, that this is a chain or some string. So the wires are like string and they are attached like this. Okay, so it is a catenary problem. Okay, so it is freely that is, the chain hangs freely between these 2 points. Okay, so it hangs between these 2 points. Now what exactly we are doing here is, or, and then the statement is also given as which are not in the same vertical line, and then the curve in which it hangs is called a catenary. Now there's a difference between, like at any instant, suppose this is my road, okay, and then what, suddenly there is a slope in the road. So what will happen, there is also one more what, pole over here, and this time this pole is of suppose 30 okay, or 50 feet, not 50, 30 feet, okay, and then see here, but these points, is this chain hanging uniformly? What will be your answer? Okay, so this is also a catenary. So okay, so what is the definition of catenary? What I'm trying, if A heavy uniform string or chain hangs freely between 2 points which are not in the same vertical line, then the curve in which it hangs is called the catenary. So this curve is called the catenary because it is hanging between these 2 points, right? Now let me explain. That is something known as, that is, what do you mean by common catenary, right? Common catenary, if the weight per unit length, okay, if the weight per unit length of the string or chain is constant, then the catenary is called uniform catenary, right? So that is the difference between, usually catenary is a what do you say, it is a curve, okay, which hangs that is which it hangs is called that is, it is usually a curve hanging between 2 points. Now at any instant, if the weight per unit length of the string or the curve is constant, then what will happen, it is called known as uniform catenary. So these two differences you should know how to vary it, right? Now this is a common catenary, okay, so from point A to B, right? So whenever solving problem of catenary, there are certain things you should know, right? Now the horizontal component of the tension at any point of the chain. Now this is your horizontal component. Now this is common catenary because every, that is weight per unit length of the string, right? So here, everywhere it is same, and that is why it is called common catenary. Now what are the things to be noted down in or the concept terminology, that is the horizontal component of the tension at any point of the chain. So here, okay, is always given by, that is T cos psi, right? So this, along this horizontal line, okay, and this, it is always given as T cos psi. The vertical component, this vertical component, okay, is always given by T sin psi, okay. Now what is, okay, vertex, the lowest point C is called the vertex of the common catenary. So this is this point is called the vertex, right? Now directrix, the axis of Y, which is vertical line at depth C below the lowest point. Now this is the lowest point, below the lowest point, this at depth C. So this is some parameter, okay, this is capital C, this is small c. So this turns out to be your, this line turns out to be your directrix. Now what do you mean by axis? So the vertical line through the lowest point C, that is nothing but through the lowest point. So from here to here, this is called your axis. So this is a general interpretation of a catenary. This is a uniform catenary, wherein the weight per unit length on the string is constant. Wherein if you talk about catenary, it is a uniform heavy uniform string or chain hangs freely between 2 points which are not in the same vertical line, okay. So in common catenary, it is along the same vertical line, right? And these are the basic things you should know. What do you mean by vertex, what do you mean by directrix, then axis, okay. Then what do you mean by span? So the span is distance covered by the chain from A to B, right? From A to B, how it is covered. Suppose this is 1x, A to B is x, and C to, sorry, A to C is x, and C to B is x. So it turns out to be 2x, right? So the distance, okay, from A to B, that is along the curve, that is along the curve, this curve, not this curve, right? Then what do you mean by sag? Sag is nothing but this distance. Where is my figure? Yeah, this distance is called as sag, okay. So this sag is nothing but it is being calculated by, that is CD OD minus OC. So this complete OD minus OC will give you the sag, okay. And parameter C, which is small, okay, this parameter C is the distance from here to here, okay, fine. So this was all about the catenary, right? Now let us move on to the catenary problem, okay. So see here, prove that The catenary is the curve which when rotated, I'm talking which when rotated about the line generates a surface of minimum area. So it generates a surface of minimum area. So solution, we have the expression for the total surface area, that is TSA, that is total surface area, given by, that is 2 pi, okay, 2 pi y over small, that is ds, right? Where the curve, this is the formula, that is for total surface area of a, that is curve which is rotating, okay, about the line. Now so let me consider rotated about the x-axis. Now I is equal to, that is integral over x1 x2 2 pi ds. It actually here this is, yeah, so it is ds, right? Yes, so ds it is, so I have multiplied it by dx and dx over here. So this ds by dx is nothing but small element, okay. So this 2 pi y is 2 pi y, okay. What is this ds by dx? See here, if you take any point x1 to x2, and this is the curve S, and if I take some part, see this is S, complete S, and if I take some part of this becomes ds, right? So some part, if I am taking and drawing tangent, then ds will be what? So ds, that is arc length, right? This is what I have discussed in the very first class, and now also I have discussed, right? So arc length will be, that is 2 pi y square root of 1 plus y prime square dx, okay. Now since 2 pi is a constant, therefore now f is a function of x, y, y prime, which is equal to, now this problem is what type of a problem? It is a function problem which contains a functional, and this can be evaluated by, that is calculus of variation, and by using Eulers method, right? Eulers equation, right? So here 2 pi is a constant. Now f is a function of x, y, y prime, and which is equal to y square root of, what is your functional? It is y, because 2 pi is a constant, y square root of 1 plus y1 prime square, now which is independent of x. So d by dx of, so Euler's equation, one of the form of Euler's equation, so d by dx of f minus y prime dou f by dou y prime minus dou f by dou x, which is equal to 0. Now d by dx of f minus y prime, okay, here, so dou f by dou y prime equal to 0. So what is dou f by dou x? That is it is independent of x, because you do not contain, it does not contain the variable x, right? So dou f by dou x equal to 0. Therefore on integrating it, I get, so this, on integrating we get what? So this integration, differentiation gets cancelled, so f minus y prime dou f by dou y prime, which is equal to c, constant. Now putting the values of f and dou f by dou y prime in 1, okay, so we have, that is, what is the value of f? It is given, that is the function, so y is y into square root of 1 plus y1 square minus y prime, right? So here it is y prime dou f by dou y prime, so it is 2y divided by 2 square root of 1 plus y prime square y, which is equal to c. Now again by simplifying this, okay, so y into, that is 1 plus y prime square minus y1 square, which is equal to, that is c square root of 1 plus y1 y prime square, not y1, okay. Therefore y is equal to c square root of 1 plus y prime square. So y square is equal to this square, which is equal to c square 1 plus y prime square. Therefore y prime square is equal to y square minus c square divided by c square. So y prime is equal to square root of y square minus c square divided by c. Therefore dy by dx is equal to, again, that is square root of y square minus c square divided by, so this is not divided by, so it is c, or I can write this equation as dy by dy square root of y square minus c square, which is equal to dx divided by c. Now this is something like as, the variables y are on one side and variables c are on one side, so therefore it is variable separable form. When the variables are separate, you need to integrate it. Okay, so integration of dy square root of y square minus c square, okay, which is equal to 1 by c integration of dx plus b. Now see here, this equation is nothing but cos hyperbolic inverse y by c, which is equal to x divided by c plus b, because already I have taken c over here. Therefore y is equal to, okay, c cos hyperbolic c plus b, which is the required equation of catenary. Usually you will arise a problem of category and end up with this particular equation, right? Okay, anytime when you solve a catenary problem, maximum time you will arise with this particular equation. Okay, depending upon c and b, you can change the course of the, that is depending upon the value of c and b, you get this answer, right? Fine. Now discuss the hanging chain problem. So it is as same. Okay, so you should discuss a hanging chain problem, so it becomes a catenary problem. A heavy cable hangs freely under gravity between two fixed points. Show that the shape of the cable is a catenary. Okay, so what cos hyperbolic it should be. So this is my point P, x1, y1, and here I will take Q here. Let me equally distribute it, and this chain is hanging. So this is some part of this S curve, and y is equal to at a distance h. Now let P x1 y1 and Q x2 y2 be the two fixed points on the hanging cable. Let us consider an elementary arc length, that is some arc length ds of the cable. Let rho be the density, that is mass per unit length of the cable, so that rho ds is mass of the element. Okay, if g is the acceleration due to gravity, then the potential energy of the element mgh is given by, that is rho, that is density, over, that is some part of, that is curve, into gh, because this is mgh, where x axis is taken as the line of reference, right? So total potential energy of the cable is given by, that is T is equal to, that is integral over P to Q rho ds gy dx, and what are the points, that is x1 x2 rho gy, that is ds, here it is, right? So what I do is this okay, so it is ds dx, right? So but ds dx is what, it is 1 plus y1 prime square, which is equal to, y is a function of xy y prime, which is here the functional value is, that is y, okay, that is y square root of 1 plus y square, right? So this problem is already done in the previous example, so kindly do it, right? Fine. So finally you end up with which is a catenary, and it can be proved that this corresponds to the minimum value of t. So problem is same, only the thing is you need to evaluate it, right? Okay, at any instant if you do come have some problem, then please let me know. Now this Beckstrom problem, so what is this Beckstrom problem? Okay, let me give you a task, right? So this Beckstrom, yeah, the spelling is mistake problem. It was established or found in the year around, that is 1626 by Mr. Bernoulli. So what happens, suppose you have 2 points A and B, right? And this is the path, this is the path, this is the path, this is the path. Okay, so which says that if a particle moves a particle of mass m, okay, moves from a point A to point B under the influence of gravity, now which path, suppose let me take these 2 points, right? And now which path it should take to reach and coming from A to B, so that it takes minimum time, so that it takes, that is minimum time. So obviously you people will say this, okay, some people will say this, some people will say this, no, some people will not say this, right? So obviously you will say this particular thing, but I say no, it will be this particular line. So that is the thing which makes this problem unique one, so that it takes minimum time to solve this problem. So to solve this type of problem, then again we use method of that is calculus of variation. Now see here, if you have this point A, okay, and let me tell you, okay, this is a straight line over here and this is here, right? Okay, this is the point B. Now if you take two ball, okay, and drop from here and drop this ball to here at the same time with the same velocity, and the same mass of the ball will be same. So if you throw here, if you start with the same instant, and this ball starts rolling from here to here, and this ball starts rolling from here to here. So which path would you choose? So maximum people will say that is, sir, I will choose this path because the length of between A and B, if measured, it is what the shortest length. But matter of fact, it is not that true. For some problems, this path in the form of some cycloid, right? So this path turns out to be the shortest distance, right? So here it is said it makes minimum time. So minimum time, not shortest distance. So what will be the time taken to travel from A to B? So minimum time taken to travel from A to B will be this path. So let us see how it moves. Okay, so find the path. Okay, so this questions might be asked like discuss hanging chain problem, discuss Beckstrom problem. So find the path in which the particle, in the absence of friction, will slide from one point to the other in the shortest time under the action of gravity. Suppose this is the initial line, this is y-axis, x-axis, this is a point P, and this is A, that is x1, y1, okay, this is P, x, y. Now let the particle slide on the curve from O with 0 velocity, and let OP, from here to here, OP is equal to S, that is the curve, and time taken from 0 to P, that is 0 to P, or you can say P is equal to T, that is okay. So 0, P is equal to 0 and P is equal to T. Then by law of conservation of energy, what do we have? That is energy, kinetic energy at P. Okay, so what is the kinetic energy at P and kinetic energy at O? So we'll take kinetic energies, which is equal to potential energy at P. So what is the potential energy at P? Now, so this is half mv square. Kinetic energy at 0 at origin, it is 0. So this is kinetic energy at P. So kinetic energy at P is half mv square, which is equal to potential energy. Potential energy is mgh, right? Or this equation I can write it as 1 by 2 m. What is velocity? It is ds, that is some displacement with respect to time square. Okay, this is v is displacement. So mgh is what? H is the height, that is y. So ds by dt is equal to this to this, and this gets cancelled, right? So this is square root of, okay, so if I take this gy is here, okay, so this is ds by dt, then this equation will turn out to be, that is square root of 2 I will take here, so it is 2 gy. So ds by dt is equal to square root of 2 gy. Now time taken by the particle to move from 0 to A. So what will be the time? Okay, now there it is, now the time taken, that is 0 to t dt, okay, it is integral over 0 to x1 ds, that is which is divided by square root of 2 gy. And if I take this 2 gy constant outside, so it is 1 divided by square root of 2 gy, and over the limit 0 to x1, fine, and ds by, that is square root of y, which is equal to, that is 1 upon square root of 2g over the interval, that is, what is this ds? Ds is nothing but square root of, that is arc length, right, 1 plus y1 prime square divided by square root of y, that is ds. Now here the given function, here the given, this is constant, so it is the functional, and the functional is square root of 1 plus y prime square divided by square root of y, and which is independent of x, that is dou f by dou x is equal to 0. Now dou f by dou y prime is equal to, that is this particular thing. Fine. So it will give me what? So that is integrating with differentiating with respect to y prime. So here in the numerator y prime is there, but in this numerator it will come out, right? So it is 1 by 2 and square root of this is that is differentiation dou f prime, right? So it is 1 upon 2 root x. Okay, so 2 is here, so 2 y prime divided by square root of 1 plus y1 y prime square, which is equal to y prime divided by square root of 1 plus y prime square. Therefore now solution of Euler's equation. So this is the Euler's equation is given. Therefore on substituting the value of f and dou f by dou y, we get, so that is square root of 1 plus y1 prime square divided by square root of y minus y prime, that is whatever the values you have got that you need to substitute in this particular equation. So this y1 and this y1, it turns out to be y1 square divided by square root of, so here in the numerator it is square root of y, so I will take it to the and this 1 plus this square root of y is common, so I will take it to the other side, or here it is 1 plus y1 square minus y1 prime square, which is equal to c into, I will take this to the other side, and if I take this here, okay, so it gets cancelled it up. Okay, fine. Therefore 1 is equal to c into square root of y 1 plus y prime square. Now 1 plus, where is my c? C is here. Okay, so what is this equation? That is, it turns out to be, now see here, this square root sign if I multiply over here, that is if I take square on both sides, so it turns out to be 1 plus dy by dx square of this, okay, which is equal to this cy, it comes to the denominator 1 divided by y c square, that is on squaring of this, right? Therefore dy by dx is equal to square root of 1 minus y c square divided by c square, or dy by dx is equal to 1 divided by c square minus y divided by y, which is equal to a minus y divided by y, because 1 minus c square is equal to a. Now so dx is equal to, from here, okay, dx is equal to square root of y divided by a minus y dy, and this is nothing but the change of variable. Then whenever I am taking the value, so 0 to x, okay, so dx, which is equal to integration from 0 to y dy square root of y a minus y. Now if I substitute y is equal to a sine square theta, so dy is equal to 2a sine theta cos theta d theta. So this is integral of 0 to theta, so that is a square sine square, so 1 minus sine square theta, and this is 2a sine theta cos theta d theta. Fine. Therefore after that is evaluation, that sine theta, this a I am taking outside, a gets cancelled, so sine square theta, so this is here, okay, so this turns out to be cos square theta, right? So this is cos square theta. See here, if I take a common here and a common here, this a and this a gets cancelled, so sine square theta divided by, this is 1 minus sine square theta, so sine square theta can be written as cos theta, so sine theta by cos theta, this square root sign gets cancelled, so 2a sine theta cos theta d theta, so 2a sine square theta, okay, this cos and this cos get cancelled, plus b, so a is equal to 0 to, that is 0 to theta, because even you need to change your limits, right? So 0 to theta, 2a sine square theta d theta plus b, so therefore a in the bracket, over the limit 0 to theta, so sine square theta can be written as, and that is 2 sine square theta 1 minus cos 2 theta theta, and over the limit over that is d theta, which is equal to a, so integration of 1 is theta minus sine 2 theta divided by 2, that is 0 to theta plus b. Now x is equal to, that is a by 2, right? A by 2 inside the bracket 2 theta minus 2, that is sine 2 theta, right? And therefore plus b. Also we have theta is equal to 0 and y is equal to 0, and we must have x equal to 0 0. Also, since 0 comma 0 is a point on the curve, this gives b is equal to 0. Okay, so this part please be careful. Okay, now thus x is equal to a by 2 2 theta minus sine 2 theta, and here somewhere it is y. Yeah, so y is equal to what? Y is equal to a sine square theta, which is equal to a by 2 integration of 1 minus cos 2 theta. Now if I put a by 2 is equal to a and 2 theta is equal to some notation, that is in terms of, this is as well theta only, right? Therefore we'll get an equation that is x is equal to a, that is theta minus sine theta, and y is equal to 1 minus cos theta, which is a cycloid. Thus this is a required curve. So what do you mean by this cycloid? So in fact, okay, so in fact I will tell you this nature of this Beckstrom problem. So this is always a cycloid, and let me show it by some representation, and see this. You can see this. So how does it move? This is a cycloid, and how it is moving. See the path on the trajectory, how it is following, right? So see here how it follows. So cycloid is always it is a curve. Suppose that there is a particle associated with that is on a rim, and rim of a wheel of a cycle, and cycle is moving forward in x direction with certain velocity, right? And the wheel is also rotating. So now the trajectory travels by that particle which is on the rim, right, which is on this rim, that is moving forward and rotating also. So this is the case, right? So what we see that the solution of Beckstrom problem are actually a cycloid. That means the problem that is the problem reaching from the point A to B is not a straight line, but it is a cycloid. It could be a cycloid, right? So how it is being termed. So here let me, yeah, okay, so what will happen? Suppose this is the point A and this is the point B. It is not always the straight line, but this part, this portion is nothing but the cycloid. So if you take like this, so any particle, what will happen? You have two particles, right? One is this, so it is moving also along this angle. Okay, so it is moving forward in x direction. That is x direction with certain velocity, and also the wheel or its circular pattern is also revolving, right? So the shortest distance will be this curve rather than any other curve. Okay, so that was all about your application part. The application part I have chosen particularly the last part. So what it is, first thing is you should know what is functional, then you should know what is Euler's equation, which is useful to solve problems of calculus of variation. Once if you are you have an idea how to solve problems with respect to, and also you should remember the conditions here, that is cases, case 1, case 2, all the four cases I have given. Apart from that, application problems used in, that is geodesic, catenary problem and Beckstrom problem, right? These are the three basic problems which are there in the calculus of variation. So you can watch any online videos also. You can solve much more better problems also, and you can take some application part from calculus of variation, and also give seminar over it. That will be very useful. Okay, at any instant if you have any problem, please call me up and ask any doubt. I am there for you, right? Thank you very much.